I'm Stanley Bizub, and this is Zach Spaeth, and we're both tutors in the Hack department. I tutor chemistry and German, and Zach tutors German and math modeling. And the reason we're doing this basic algebra review today is because it's required in a variety of disciplines, including physics and chemistry, as well as your business and economics courses. And you're also required to take courses in math for your degree. So we'll start off with an outline. We'll cover exponents first, and then functions, multiplying polynomials, factoring, graphing, and that'll be the basic outline.
The first set of exponent rules is the definition at the top. A of n, so any number to the higher power of another number, is simply a times a times a as many times as you have the higher number. And then for the first example of the rule is a to the negative n equals 1 over a to the n. So it's just the inverse. And then the main example that we'll see often is a to the 0 equals 1. Whenever you take a number or a variable and put it to the power of 0, it's always the number 1. A to the 1 is a. You're not multiplying it at all. A to the n times a to the m, you add the exponents, so it's the quantity a to the n plus m. You have a times b to the quantity n. It's a distributive property, so you distribute and it's a to the n times b to the n. And lastly, you have the quantity a to the m to the power of m, and its multiplication, so it becomes a to the n times m. And then we'll move on to a few examples. The first one would be x to the third times x to the fifth. And what you do is, if you look at the rules to the right, it would be 3 plus 5, so the answer would be x to the 8th. Excuse me. For the next one is s plus 1 to the 4th times s plus 1 to the negative 3rd. It's almost the same thing we did above, except there's an extra number on the inside of the parenthesis. It's to throw you off a little bit. So you do the same thing, add the exponents, so you get s plus 1 to the first, or just s plus 1. And then for the last example, it is 4 to the n times 4 to the n plus 1, and then the answer would be 4 to the n plus 1.
Now we'll move on to functions. Recall that f of x in a function is nothing more than the fancy way of writing y equals, and you can use that to graph and also look at other functions. One example here, f of x equals negative x squared plus 6x minus 11, and that's just as easy as writing y equals negative x squared plus 6x minus 11. And in order to find f of 2, f of negative 3, and f of t, you simply plug in the value or the variable into x. So if you want to give those a try, and we'll go over them in a minute. And the answers are negative 3 for f of 2. You simply plug in 2 and evaluate the function, and you get negative 3. The second function problem, which is f to the negative 3rd, looking at the function negative x squared plus 6x minus 11. And we can just look at this as y equals negative x squared plus 6x minus 11. And when it says f of negative 3, that simply means plug the negative 3 in. So you got to remember the negative from the original function. And so you have negative 3 squared, which is actually 9, but you have to remember the negative sign, so that would be negative 9. And then plus 6 times negative 3 is simply minus 18. And then plus 11. Or, sorry, minus 11. And that's from the original function. That equals negative 38. And f of t, these are some things that you'll run into in the math classes. You have to plug in variables as opposed to numbers to get a new function. And that simply equals negative t squared plus 6t minus 11. And now moving on to multiplying polynomials. The rules are first, outer, inner, and last. And if you see the little picture here, the man with the big nose, and you can point out that the first is x times x, and then outer would be x times 5, and then the inner is negative 3 times x, and the last is negative 3 times 5. And you can evaluate that function.
So if you take a look at the examples in front of you, go ahead and take a few moments and try those examples. We'll put the answers up in just a few moments. And now the answers, 7x minus 4 times 7x plus 4. You do the first, so 7x times 7x is 49x squared. Do the outer, so 7x times 4 is 28x. And then the inner is negative 4 times 7x, negative 28x. And then the last is negative 4 times positive 4 and negative 16. The positive 28x and the negative 28x cancel out, and you simply get 49x squared minus 16. The next one is the same as the first one. You just do the first, outer, inner, and last. You get 4x squared minus 20x plus 25. The third example, which is 2 times the quantity x plus 3 squared. The first thing you can do here is expand the x plus 3 squared to become 2 times x plus 3 times x plus 3. Now you can apply the FOIL rule. So x times x is x squared plus the outer plus 3x plus the inner plus the last, which is 3 times 3 is 9. And then don't forget the 2 from the original function. And then you can combine the inner 2 to become 2 times the quantity x squared plus 6x plus 9. Lastly, you distribute the 2 to each of these values to get 2x squared plus 12x plus 18.
Now here's a little pop quiz. This has nothing to do with the basic algebra. We just wanted to add a fun element into it. But if 1 equals 5, 2 equals 10, 3 equals 15, 4 equals 20, then what does 5 equal? How many of you said 25? Because that's a very common answer. You'd be wrong, because 5 actually equals 1 if you go back to the original. The first top one, 1 equals 5, so 5 equals 1. And then some people have a lot of problems with word problems. How I see math word problems: if you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. The important thing about word problems is to break it down into what is important, and often very few numbers or functions in the word problem are important to you, so just take those and go from there. Now we'll move on to order of operations. PEMDAS is very important to use. You may have seen these problems on Facebook, and a lot of people get them wrong because they don't remember PEMDAS. Parentheses first and then exponents. And then you do multiplication or division, not multiplication before division, just whichever one comes first. Multiplication or division from left to right. And the same goes with addition or subtraction. After you've done your multiplication and division, you do your addition and subtraction from left to right. So if you want to give this example on the slide a try, go ahead. The answer is 14, because first you have to do the 1 times 0, and that equals 0. Then you add up all the numbers, and don't forget the minus sign in between the problem, and once you add up all those ones, you get 14.
So we'll go ahead and move on to factoring. Two of the main formulas you'll see is ax squared minus bx plus c, or also ax squared minus c, where the bx is just simply canceled out. So if we look at the common mistakes, it's 100x squared minus 81. That does not factor into 10x minus 9 squared. The distributive property does not apply here. You have to multiply 10x minus 9 times 10x minus 9, so it would be the reverse for factoring. So one of the main things for ax squared minus c is you find the common factors for a and b. So common factors for 100x squared minus 81, you look at 100, 10 and 10, 5 and 20, 1 and 100, like that. And you can automatically assume 1 and 100 won't really work in this case. And then the same thing, you go on to 81. Common factors would be 9 and negative 9. And then plug them in, and you get 10x minus 9 and 10x plus 9. It's more of a chug and plug, and just figuring them out as you go from there. And then if you look at the examples, go ahead and try those, and we'll go right over the answers. So the answers for the first one, 100x squared plus 81 cannot be done. It would have to be in the form ax squared minus c to be completed, and you cannot factor this. For the second one, 3x squared plus 13x minus 10. So for factoring problems, the easiest thing to do is don't forget what the original type of equation was. So ax squared plus bx plus c. The easiest way to do this is to find common factors for a and c, and then work from there. So you always have the form of this with x here and an x here. So common factors of 3 are 1 and 3. So we can put a 3 here and a 1 here. And then common factors of 10 are 1 and 10, or 2 and 5. So we'll go ahead and try minus 2 and plus 5 and see if that works. So 3x times 1x is 3x squared. 3x times 5x is 15x. Negative 2 times x is negative 2x. And then the last one, negative 2 times 5 is negative 10. So that is the correct one. You get, if you were to multiply it again, 3x squared plus 13x minus 10. So the correct answer is 3x minus 2 times 1x plus 5. So now for an example, if we had tried the reverse, positive 5 here and a negative 2 here, you would have 3x times x is 3x squared, 5 times x is 5x, the outer 3x times negative 2 is minus 6x, and the last is plus 5 times negative 2 is minus 10. You get 3x squared minus x minus 10, which is not the correct answer that you started with for the function. So you would have to do the opposite of 5 and 2. And for the last one, it's even simpler. 5x plus 1 times 5x plus 1, which is also equal to 5x plus 1 squared.
Now we'll move on to graphing. You're probably familiar with the equation y equals mx plus b, where m equals the slope, which is the rise over the run, or maybe the fall over the run when looking at graphs. And an example would be y equals negative 2/5 x plus 3. In order to find b, which is the y-intercept, you simply plug in 3. So when x is 0, then y is 3. So you plot that point, and then you simply use the m, which would be negative 2, so you fall 2 and go over 5. And we'll move on to one more example. And this is in a little bit of a different form. It's not y equals mx plus b. So instead of being a linear straight line, it would be in parabolic form, which forms a little U-shaped parabola. The equation y equals x plus 3 squared minus 1. The vertex is located at the point negative 3, negative 1. You need to set the equation equal to 0 and solve for x. And when you set the equation equal to 0, first you add 1 to each side, and then you take the square root of both sides. So x plus 3 equals plus or minus negative 1. Don't forget the plus or minus whenever you're taking a square root. And you get x equals negative 4 and x equals negative 2. So two of the points on the graph are going to be negative 2, 0 and negative 4, 0. Because this parabola, the vertex is at the bottom, so it points up, and that helps you graph the parabola.
Then for the final part, we'll move on to some common graphs that you'll see in any of the math classes. A lot of them you cannot draw or find the points by hand. It's easier to use your TI-83 or TI-84 or even mathematical programs. So for the first one, we have y equals the square root of x. If you notice, you cannot take the square root of a negative number, so it's only in the first quadrant. The next one's y equals x cubed, and then y equals absolute value of x. It cannot go below the x-axis because of taking absolute value of negative numbers. Can only work like that. Frequently seen in business and econ classes for interest over time, we have y equals e to the x. It can also not go below the x-axis because you cannot have negative interest. And then the opposite, the inverse function of e to the x, is ln of x, which you notice does not go on the left side of the y-axis as it cannot have a negative number.
We have one last joke there. You won't get any points for pointing out the x's there. If you have any questions, feel free to go to the Hack website on the RMC page or the Facebook page, and you can contact a math tutor or even a chemistry or physics tutor, possibly a business or econ tutor that could help you with basic algebra.